Hello everyone, we are from Group 12. Today we gonna present a mini project to do from Arduino board. Okay, first we want to talking about project concept. We decide to develop the smart room temperature control system for the product storage because the temperature stability is very important when it comes to preserving certain goods, especially food, medicine, and the sensitive electronic. In many cases, a small change in temperature can cause damage, spoilage, or reduce the quality of the stored product. Our goal is to create an automatic system that can help maintain the proper temperature range without the need for constant human supervisor. Okay, now we want to look at the circuit. Yeah, first one we use passive buzzer and how it works. Passive buzzer, when the electrical signal is applied to the buzzer, is cause piezoelectric crystal inside the buzzer to vibrate at the specific frequency. The next one we use DHT11. Um, it's used capacitive humidity sensor and the thermometer to measure the surrounding air and spread out digital signal on the data pin. Yeah, it's fairly simple to use, but require careful timing to get data. Next one we use LCD I2C. The I2C interface is used to send initialization commands and RAM data to the display controller. This is done through the clock line and bit decretion communication line to two required communication signal, SDA and SCL. Okay, working principle. Yeah. Uh, yeah. We from the picture when the DHT11 receives the temperature and humidity, it sends the signal to the two devices is LCD I2C and passive buzzer. Okay, after that, the I2C will display the measured temperature and humidity. It's shown, but uh, when it's shown, the display temperature does not meet in the condition uh, like said in the code. Yeah, the passive buzzer will send a signal surround the make a sound. Yeah, round sound.
Okay, so I'm going to explain the code part of our project, which is called the Temperature and Humidity Monitoring System. This project is designed to measure the temperature and humidity using a GHT11 sensor and shows the values on the LCD display. So if the temperatures go outside of the normal range, a buzzer will alert the user. So let's start with the libraries at the top of the code. In first line, we include wire.hash. This line is allow us to communicate with the LCD using I2C protocol. And next one, we also include this line. This line is just for controlling the LCD screen. And next we include DHT.hash as well. This line is used to read the data from the DHT11 sensor. And then we define some of the pins. First we define DHT at pin 2. This is where we connect the DHT11 sensor. And next we define the buzzer at pin 8. And next we define the type of the DHT as well, which is the DHT11. Then we create objects for the LCD and DHT sensor. This line, it told us that the LCD is used the address 0x27 and it is a 16x2 display, which is 16 column and 2 rows. We also initialize the DHT sensor object so we can use it to read data later. In setup function, we initialize all components by starting with the serial monitor to help with debugging, and then we initialize the sensor, the LCD, and the buzzer pin. The buzzer is set to output mode and turned off by writing high because it is an active low buzzer. And next we display some welcome message on LCD as well. We use this line for greeting and introducing our team and our project. And we also use LCD.set cursor. This line is set the starting point for text on LCD 0, 0. This one means the column 0 and row 0, which is the top left corner of the LCD. And we also add some delay between each message to give time for the user to read it as well. And then after the introduction, we clear the LCD to prepare for live readings. Now let's move on to the main part of the program, which is the loop function. In this part, the system constantly reads the temperature and humidity values. In this line, we store the values into float variables, which is humidity and temperature. And next, we check if the sensor is working correctly by using this line. So if the reading is fails, it shows sensor error on the LCD. This will help us know if the sensor is disconnected or not working. And then we show the current temperature and humidity on the LCD using this line. And the value updates every 2 seconds using delay 2000. And we also send the same data to the serial monitor for debugging as well by using 0.print. And now come to the most important part, which is the alert system. We want the system to warn us when the temperature is too hot or too cold. So if the temperature goes above 30 degrees Celsius or below 20 degrees Celsius, we will trigger the buzzer by using this line. And then we activate the buzzer in this loop. The buzzer beeps twice, each beep lasting a half second by using delay 500. So this will create a total of 2 seconds of alert sound, and it also syncs with the warning text as well. After that, the system continues to loop and read the data again.